I'm going to share my screen. Okay, please confirm if you can hear me properly and if you can see my screen. Can you hear me properly and can you see my screen? Okay, we start.
Yes, yes, so I can hear you.
Okay,
Yes.
thank you very much, Esther. Thank you, Christina. Thank you, everyone. Okay, so today we're going to do chapter 3 and 4. So when you go in our NetCAD and we start the course, we'll see that we have some chapters. We'll have some chapters. What are they? So we have chapter 1 to chapter 17. We are very short chapters, huh? So don't panic. Don't. I'll make it very simple, easy for you. And anytime you have questions, please post in the group and we'll help you. So we started with networking today, general information. And for you who did IT essentials, it's good already. Then we started doing basic switch and PC configurations. We did a bit of packet tracer, how to connect stuff. And also, please, guys, send me all your assignments because I'll need to send to update Scalabrini. And we need all this stuff. We want to make sure that the student will participate. We do assignments, we do chapter exams, you see all this stuff. And also that will help us for job interviews. This question I'm asking, it's the same we ask for job interviews. So on Saturday, I'll do all the answers. I'm waiting for other students to send me the work. Then Saturday, I'll do, so Saturday we have class at 10:00 online. I'll do the answers for the assignment number 1, the packet tracer with color, the very first one. We'll do I'll show you the answers for the questions, the 12 questions. Then assignment number 3 is what we did last time on Monday. So that packet tracer I did, and I got 100%. I did send it to you. Yourself, do it and send it to me before Saturday. I want to double check if really you do your homeworks, if really you practice packet tracer, because CCNA is good theory and a lot of practice. You should know how to manipulate equipment, fix equipment, troubleshoot equipment. So today is chapter 3 and chapter 4. We are theories. So I'll try to combine these two in one. Protocols and models, it means if we need to communicate, two PCs need to communicate, they need to agree on many things. The language, if I speak to you in French and Christina is Portuguese, she won't understand. If I speak to you in Spanish and you are Chinese people, you won't understand. So we need to agree on many things. The rules. You have a nice video explaining, but we need to agree on some rules. We all need to speak English, speak slowly, and so we have some rules. How the message is when you create your email, you want to send an email to Mr. Max, you do it and you press submit. What happens in the background? So it's a bit of physics. We try to explain to you here in message encoding. You don't need to memorize, just to read many times, just to have an idea. Message size. Do we need to speak very slowly or very fast, or So we need to agree on how are we going to communicate. And all these rules, they explain in the video and also here. Then comes protocols. Protocols is also the same thing. For example, if you want to register at Scalabrini for CCNA, either you have a bit of IT background first, or you have done IT essential course. So anything we do, we need some rules. So network protocols is some rules. So if I click here, for example, some rules. Like you're here, you send your data to the server, your email, hi, Mr. Max, my name is ABCD, this is my assignment, thank you. And you press submit, we call it the data. So when the data leaves your PC to go, now I'm lost. So when your PC leaves the PC to go to the network cable, other information will be added, like IP address, MAC address. It's like the post office. When you have your parcel and you want DHL to come and collect, they will collect and they will put them in a DHL box with some way bills, some information. So your data will be surrounded by other info to go. We'll have time to do a lot of these things. You see, when your message is leaving, you have many things, many information inside. So that if a police guy stop you, he say papers, he check you, okay, you're going to maybe China, it's fine, you can go. Or they stop you, you want to go to China, no, you cannot use our way to go to China. Go back, fix, and choose the best way. So all these protocols, for example, if you want to use the web, we have some agreement how two PCs will use the web. If you want to use the network cable, what type of network? So we have some rules that we agree before we communicate. So there are a lot of, so this chapter is more about protocols. We'll check network protocol, TCP, IP. So in IT, especially in networking, we're going to organize the networks. So in a network, what will be the different parts? For example, so we have, let's say, the British way and the Russian way, for example. The British way, we're going to say, okay, for us, how are we going to organize the network? We're going to call it TCP IP. If it's the Russian, they have their own way also that we'll study. So TCP IP protocol is a set of standard to see how to organize the network. In this, we're going to say, okay, we organize the network in 4 parts. One part will be the network access. Anything related to cabling, we put it in network access. We're going to have internet part, internet section. Anything related to IP addresses falls in that section. Now, to send and receive, the system that will make sure that when you send your data, it will reach destination. We call it TCP, transmission control. So when you transmit something, transmission control protocol, we put it in transport section. Now, if you want to read your email or watch your YouTube, or we call it the application, or here, the application layer. And we put anything related to the web, because you access most of them via the web. We put them here. In IT, it's compulsory to know TCP/IP and how it's organized. That's all, you see. So just how the network is organized. We'll get more info. So here is more in details. In the network access layer, we have all this information. Sorry, that we'll do a bit later. Internet layer, anything related to IP addresses. Transport layer, we have TCP and UDP. In application layer, like emails and web, anything else is. So if you need more info, everything is well explained. Like application layer, this is all the information. Transport layer, we explain here. And then internet, network access. Anytime you have issues, post in the group, will help you. So let me play this guy. So what is it? You're doing some web research. For example, you want to apply for a job. You read, you send your CV, you attach your CV, you fill the form, name, surname, and what. Then you click send. When you send, you see, when you send, what you did is called the data, the normal data. Now, that data needs to travel. It's like you're in Angola and you want to travel. You need a passport, you see. And in that passport, you need a visa. So it's the same thing. You cannot just go alone like that. You need extra info. So the first info, when you have the data, they're going to add some information for the transport. How are you going to use DHL or South African Post Office? Then what is your IP address or the address of the guy who's going to read your letter? Then it's going to go via the cabling, Ethernet. So when everything is well done, to go to the network cable, everything will be divided in 01010101. 0 or 1, we call it a bit. If I group 8, we call it a byte. We'll have time to do that also. So for now, we go step by step, slowly. So this is how, when you press enter, a lot of things happens in the background. So as IT engineers, we need to understand that. That's why this course has been designed. So your data will be encapsulated. It means it will be added more info when you send. And the recipient, will use de-encapsulation. It's going to remove the envelope, remove the box of DHL, remove your envelope, now grab your letter to read. We call it decapsulation. So this guy will receive the whole packet. He's going to remove the box from DHL. He's going to remove your envelope. It's going to remove maybe your, I don't know, anything. Then it will stay with your letter, your normal letter, and it's going to read. This is how communication works in IT. So you'll have time to watch it many times, check your knowledge. Now, we have something called standard organizations. We have big companies that are going to roll. It's like we're in South Africa. Anything relating to papers is Home Affairs. Anything related to education is Department of Education. So we have some big companies that will manage some department. So we have many, but I'll explain to you. So IEEE, we have their own way of working. IANA, these guys, this guy will say, okay, you, Christina, this is your cell phone number. This is a number you can use. We can say, Denise, okay, this is the number you can use. Talent, this is a number you can. So they assign IP addresses. So each of them will have their own way of working. So we will explain each of them. The Internet Society, how everything is well organized. You can get time to IANA, you see. We're responsible for IP addresses, domain name, like www.cisco.com. This guy, we manage it. And port numbers, when you have your laptop, you do emails, you do YouTube, you do anything. How the PC will know that this data is email, this data is web, this data is. We have what we call port numbers. So in your PC, in your network card, it's like a parking lot. We have so many cars we can park with a number. If you work for CPUT, for example, we say, okay, you guys use parking from 1 to 10. If you come from Scalabrini, use parking 11 to. So the network card will know if you use parking between 1 and 10, you say, this guy is maybe email addresses or what. So port numbers. Each application you use on your laptop is well organized like parking lot. So you get more information to. So IEEE, we'll get more explanation here. EIA, we'll explain more here. Okay, so on top that side, we did check the British way of how to organize the network. In a rational way, we're going to say, okay, for us, we have our own way to organize the network. We're going to call it OSI, the OZ model. This one, any network engineer should know it. And the rational, we say, okay, for us to organize the network, we're going to have 7 layers. Layer number 1, the physical layer. Layer number 2, the data link layer. Layer number 3, number 4, number 5, number 6, number 7. In blue is the British way. British way, we say, okay, this is we're going to organize the network in 4 sections. But Russians, we call it OSI model in 7 layers. Per section, we'll see what is inside. So this one, please read it nicely. Your next assignment for the questions, I'll ask you. So each section is explained here. And me too, I'm going to explain to you shortly. The British way, TCP/IP, this is how we decided to organize the network. So you can compare them. Okay, data encapsulation, it's just you write your letter, you put in the envelope, you call DHL to pick up, we're going to put your envelope in a DHL box, we call it encapsulation. You're wrapping your data. So yeah, there are a lot of information here that not to. So your normal data is here. Then you're going to put it in an envelope, like transport header will be added. Then the network, you're going to write the address of the recipient. I'm sending this one to Max Cadio. He stays in Washington. What you see? When everything's ready, DHL will come and start sending, put it in the plane to go to America. So to go to America, everything is divided in 0 ones. 1 digit, 1 or 0 is called a digit or a bit. If you group them in 8, that group is called a byte. So your data, when it reaches the transport layer, the transport will add a transport info. Then your packet is no longer a data, it's called a segment. At the network layer, you're going to write your IP, your recipient address. We're going to call it a packet, a frame, and bit. We'll have time to do many times. No worries. I try to make it very simple for you. So for your packet to leave your PC and reach destination, your packet needs 2 addresses. I think we did that in IT Essentials. You need an IP address, a physical address. If I go to CMD and I type IP config /all, and because I'm using my Wi-Fi, I can see 2 addresses, the physical address or the MAC address. It's very important. And the IPv4 address or the logical address. These 2 addresses are compulsory for a data that leaves my PC to go to a destination. It's how people are identified. So if I want to call Esther, for example, I need Esther number. So in IT, we need both physical address and the IP address to leave your PC and also to reach the destination. And in IP address, you need your source IP, where the data comes from, and the destination, where are you going to? This is the IP packet or the layer 3. We also need to add a layer 2 address or called the MAC address, source MAC, destination MAC. Without that, you cannot go. It's like your driving license. Without a driving license, you cannot drive. So these are the two parts: the network layer or IP addresses, source IP, destination. And we also need the physical address or the MAC addresses, my MAC address, source MAC address, and your destination MAC address. Then the data knows where to go. Anything else, we'll do a bit later, no worries for that. I'm trying to make it very simple, and I give you what is the most important. Then all the stuff you can do a bit later. When I do a packet tracer, we'll come back to do some revisions. So always when a packet leaves, we have these 2 groups: MAC address part, IP address part, source destination, source destination. If you see NIC, NIC means what? Network interface card. We'll use at a later stage a software, Wireshark, to grab traffic and to analyze. You see these traffic cops, sometimes they hide on the highway and we have a scanner to check who's speeding or, yeah, it's something like that. We'll do a bit later. So that's all for chapter 3. How are we going to communicate? How a network is organized? The British way, TCP/IP, the Russian way, OSI model. What is encapsulation? What is decapsulation? For a data to travel, we need 2 sections, MAC address and destination MAC address. Source IP, destination. And that's all for this chapter. Any questions before we do chapter 4? No questions. As you know, at any stage, we have a WhatsApp group to help each other. Okay, now we continue with chapter 4. Chapter 4 is about the physical layer. So now we're going to study layer per layer. So I want to make it very simple for you here. So what we're going to study, we're going to study the Russian way, the OSI model. I made it very simple here. If you want to copy, you can copy the screen. And you open the Microsoft Word document. After that, you can also copy the screen, the data link or layer 2. And this is for the top here. You can also copy the screen and paste in your. It's more easier for you to have a big picture. Then when you read NetAcad, you have more info in the video, more info, and yeah. So let's do chapter 4, the physical layer, how the network is organized. With OSI model, we have 7 layers. Layer 1, the physical layer. Layer 2, data link. This one you must know by heart. Layer 1, physical layer. Layer 2, data link layer. Layer 3, layer 4, layer. So per layer, we're going to study each of them. So let's start with the very first one. In the physical layer, anything related to the network cables, the cabling that we did last time, anything related to fiber, wireless. So the physical layer consists of electronic circuitry, media, and connectors. Anything related to cabling or media. We did study that for a network cable, the copper. We have straight cable, crossover cable, and rollover cable. And per cable, we have UTP, non-protected, protected, and a cable for the TV, like DSTV cable stuff. We call it a coax. Then we have fiber optic. So anything related to media, we put them in the physical layer. Then we have the wireless. If you want to use a wireless, we need, if all your cell phones, you go to a meeting and you want to use the Wi-Fi, at the ceiling, there is a device. It's called access point. I'm going to show you. Access point. Access point. So it's a device that will allow your cell phone to connect to it. And this device is connected to a switch, and the switch is connected to a router, and the router is connected to the internet. This is what we call access point. So you see on this picture, I hope it will be bigger for us. You see all your laptops, your cell phones will get connected to the access point. The access point is connected to a switch, the switch is connected to a router, and the router is connected to internet. You see. So that's all for physical layer. There are a lot of readings there, but mostly it deals with all these guys. Sorry. Now, so I give you 1 more minute to read this properly, and I'll explain to you in 20 minutes. So 1 minute to read, and we do it 20 minutes, and we are done for today. Okay, let's start. So we're going to study the different type of cabling. We're going to study a bit of the fiber, and we study a bit of wireless. Let's check. Okay, let's go in NetAcad and check chapter 4. And at the introduction, we're going to explain a bit why we need a physical layer. And this is, for example, a wireless router. So if you work from home, all of us, we have something like that. If you use Rain, it's a box. If it's another company, it's something like that. And we're going to explain in this router has all this. Okay. Okay, the physical layer. I try to make it very simple for you. So the physical layer is layer number 1, a layer 1. CVX, they give sometimes too much info, and the students gets we get lost sometimes because it's too much. That's why I try to make it very simple like that. Anything else is extra info. So inside, if you have a network cable, inside it's electrical stuff. So for us, we don't need to study these things. So here, for network cables, yes, we have the straight through cable, the crossover cable, the rollover cable. But inside, if you take a cable and you cut it, what are you going to see inside? We have 3 types: UTP, non-protected, STP, protected, and coax. These are the 3 here. You see the UTP, it's open. The STP shield, you have your stuff, but it's protected by something. It's more secure. And we have the coax cable, like with DSTV or with TV, old TVs. Okay, we continue after you watch that. So now we're going to explain each of them. It's only information. UTP, unshielded twisted pair. We explain what. STP, we will explain. It's more protected, you see. On top here, it's open. It's so if you have some electronic stuff around, you can lose connection. But here, it's protected. So if you want to buy a network cable, make sure it's STP. It's more secure, more, you see, it's nice. Then this one is for more for TVs or DSTVs or I don't know. Now we give you more info about UTP. A lot of info about UTP. Cat 3, category 3, category 5, category 6. So the most used is this one, Cat 6 STP. It's protected and it makes your data will travel safely. And at the end of each cable, a network cable, we have RJ45 for PCs and RJ11 for telephone. So RJ45, which goes to the wall, and yeah. In the old days, we had to build network cables, but nowadays, no. Everything's you buy. You go to take a lot, take a lot network cable, That's all you buy and done, finished. There is no need to. Uh, if you want to build them to make yourself, it's your own decision. Else, you just need to buy them. That's all. They can be 10 in the plastic, 20, and also the length. How long is it? 5 meters, 10 meters, 20 meters. It's up to you. So you see Cat 6. You see the length from 1 meter to 20 meters. So you check which one do you like and you order. But in our time, in the old days, you need to build to make it yourself. If you do something like that, is bad. You see. But if you make something like that, it's good. Everything should go inside the connector, not outside the connector. You see, no space. Everything should be inside. Then here we'll explain to you the difference between a straight cable and a crossover cable. Yeah, you could do some readings, not too much important. Now we come to the fiber. So you see that here we are done for the cabling. If you take a network cable and you cut, you can see a UTP or STP. The most used is STP, category 6, Cat 6. Sometimes Cat 5 is still there, or the coax cable. After that, you'll study the fiber. It's what we're doing now. Fiber, and you can read. This is how it's connected. At Scalabrini, I think I did show you some type of fiber media. You have single mode and multi-mode. We'll explain single mode. This is how it is. Multi-mode. This is how it is. So single mode, I even don't see the difference. It's only maybe here. The signal inside. It's only one line. And multi-mode, it's so you can read them. It's no just for information. And the connectors are here. You can do some research. You can go to YouTube. YouTube. And you can type network, no, fiber cables. And yeah, you document yourself. You check what you like. Mm. Fiber cable beginners. So yeah, you can get some small nice videos if you want to. This one looks a bit more interesting. This one is good. I can send it to you in the WhatsApp in the chat. What is the chat? Chat with everyone. Yeah, you can use that. You can watch it also. It's nice. Yeah. So here you check a bit of some info about fiber cabling. That's all. Then here we compare why you should choose a network cable, or when and why you should use fiber. We have some stuff here. After that, after you get some info about fiber, we have single mode and multi-mode. Then you check some connectors. Some connectors. Yeah. After that, the last one is the wireless. Wireless media. What is it there? Wireless LAN. I want to check something more interesting. Okay, so for wireless, we didn't explain too much. I think we have a chapter for wireless at the third part of CCNA called CCNA3. So what we are doing is the first part. We have three parts. The first part, so this is the first part, introduction to networks. Then we have part two. It's switching, routing, like what I'm taking at CPUT. I'll show you CCNA2 is switching, switching, routing, wireless. We go deeper, more configurations, more troubleshootings. So it's very interesting. Then we have CCNA3, enterprise networking, security, and what. So it's a very good course, guys. As I explained to you many times, I got my first job in South Africa with CCNA. Because you touch many things, you see, and you have good knowledge. So for this one, it's just for wireless, properties of wireless media, the coverage, interference, types of wireless media. Okay, depending on the distance, Bluetooth covers and communicates distance from 1 to 100 meters. Wi-Fi is a bit longer And if you need, for example, for a city or a town is Y max. And this one Zigbee, I don't know. This one is American guys, American stuff. So in a wireless LAN, we need an access point. So, and the access point, all our laptops, cell phones will get connected to the access point. So you need to place an access point and configure. We have two types, a single one or a managed one. Normally we use the managed one because it's linked to the switch. You do the configuration with switch. And if you have 50 access points in your school, the configuration you made in the switch will push to all of them. So you need access point, and access point is linked to the switch. The switch will get connected to the router to the internet. So that's all also for this chapter. That's why I made it very simple here for you. The physical layer. Next time on Saturday, this Saturday, we have class at 10 online meet, Google Meet. We'll do the other chapters. We'll do, it's only theory. Huh? We'll do chapter 5 is very important. Number system, yeah, chapter 5 is very important. I'll explain to you. Then after that, we go to layer number 2, data link layer. Very simple also. So Saturday, we'll do chapter 5 and 6. It means your first exam that covers chapter 1, 2, 3 is open. Take your time to do it. Don't delay too much. Give yourself 1 week and you do it. When you do your stuff, as you know, like Cisco is monitoring everything we do. And we have all your grades that will show up here. And talent is here, Daniel Sito, David, Denise, Charlie Kayambe, Dominic. So all of you guys, all your marks will be displayed here. Any questions, guys? Any questions? Any questions? So if you don't have questions for now, it's fine. If you study, you read, and there is something you don't understand, post in the group, and we'll help you. Okay, guys, if no questions, thank you very much for today, and we meet again this Saturday, 10 o'clock, Google Meet. Don't forget to submit all your assignment if you didn't do. The first assignment is that small packet tracer I sent with colors. The second one is the questions. The last one is the packet tracer we did on Monday, and we got 100%. What we need to configure the name, the 3 password, do it. Make sure you have 100% and you send it to me. Even if you don't have 100%, send it to me before Saturday. I'll check and help you. Thank you, guys. Have a good evening. Be safe. Tomorrow it seems like it's going to be bad. Let's pray. Be safe, guys. Thank you very much. Bye-bye.
Hi, sir. Thanks a lot.